Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at implementing a ring buffer class. So we're not going to see any really new C++ in this particular tutorial, but I'm just going to kind of show you an example implementation of a ring buffer. So if you're already pretty comfortable with that, or you're just not interested, then feel free to skip this particular tutorial, because we're not going to see any new C++ concepts here. So I've copied my ring.h into this new project here, and in the last tutorial I showed you some example code. Let's just go back to that. So this is kind of what it should look like in the end. Let's copy this and go to this project here, the new project, and paste it in. So let's uncomment it as well. So I'm going to go to source, remove block comment there. That seems to have worked. Format the code. So we haven't implemented these methods, and we need to implement them. This is not going to use iterators, so it's not going to make use of our nested template iterator class yet, but it's just going to implement straightforward ring buffer. So we'll go to ring.h here, and we're implementing everything in the header file because it's a template class. So we need to have somewhere to store our values. That's kind of the first thing. So let's say private here, and we need an array, and we want the array size to be specified by the constructor here. So we need an array of type T. So let's say T, and I'm going to follow the convention here of prefixing member variables with m underscore, or often in C++ you just see an underscore, which personally I think looks a bit messy, but it's a very, very widely used convention. Rather than just an underscore, I'm going to use m underscore here. So this is going to be T pointer. It's going to be a pointer to an array of T's, whatever that is, strings or whatever. And we need a constructor here. Let's maybe implement it under here. In fact, I'll give it a new public section so that we don't have to mix up this with various methods. Let's say here ring, and that's going to take a size, which is going to be the size of this buffer here. So let's say m underscore size, and pass in the size parameter there. Once we've got the size, we need to create a buffer of the appropriate size. So we can say m underscore values equals new t, remember that's our template type, new string, new int, whatever it is. And we need array brackets there, and we can pass in size, like that. We mustn't forget to delete that. So if there's not enough memory here, that'll just throw an exception, and the user will have to catch that, or else the main program will stop. So that's fine. Oh, I haven't implemented m underscore size, so let's do that as well. Let's say int m underscore size here. We could also initialize m underscore values to make it null or something, just to make sure we don't get any like compiler warnings or anything. So let's say m underscore values null, and if you've included any standard headers, you should probably pick up null there. You could also just use naught to initialize that. That would also work. So we're just setting the pointer there to point at the 0 memory address. It's not going to compile yet because we haven't implemented a load of stuff, but null is kind of more normal for pointers, which is basically equivalent to naught. Okay, so we need a destructor to deallocate this memory. We mustn't forget to put that in. If we allocate memory, we always have to immediately think, how am I going to deallocate this? So let's put a destructor in here. I'm hoping I can remember where I've got my caps lock on, that's why it's not working, where on this Hungarian keyboard I can find the tilde character. Let's say ring, so that's our destructor, and we can say delete and m underscore values. If you try to delete a null pointer, you get a horrible crash usually, but it shouldn't ever be null, because this should have thrown an exception and the whole program should have stopped if it couldn't allocate the memory. So now we've got enough memory, and we know how big this is, we can implement a size method so that this kind of thing's going to work. So we can just implement a method that returns the size to make it easier to loop through. Let's do that. So let's say int size, and all we have to do there is return m_size. So how about the add methods? Well, yeah, we need a method called add. So it's going to be void add, and it's going to take t type, which we'll call value, and it's going to add that to the buffer. Where does it add it to the buffer? Well, we need to remember the current position in the buffer. We need to increment that position as we add a value, and if we go off the end, we need to wind the position back to the beginning. So let's here have a int m_pos for position, and I'm going to initialize that to 0 here. I'm taking care to put my constructor initialization list in the same order as these, because although it would compile if we had this in a different order, this particular compile gives me a warning about that, so I'm going to initialize them all in the order that they are declared. Now to add that to the buffer, so we've initialized the position to 0, all we have to do is say m_values and m_pos equals value. We've added it to our ring buffer. Now after that we want to increment m_pos, so we want to say m_pos++, and then we need to say if m_pos is equal to m_size. So if you've got like 3 items in the buffer, m_pos can only be 0, 1 and 2. We start at 0, so 2 is already item 3. And if it equals size, now after we increment it here, clearly we've gone off the end of the buffer. We don't want to then use that to write a value, so we want to set it back to 0 because it's a ring buffer. Let's say m_pos equals 0. So that should work. I've incremented pos separately here. A lot of people would put ++ in here. That's probably even the most common syntax for this situation. So we're using the value. Remember, it's postfix here, not prefix. Postfix, it's after the value. So we're using the value and then incrementing it. And then we can check the incremented value down here. So I'm not a huge fan of that because this can end up making the code look more complicated, but I'll do it here because it's probably the most common thing that you would see. So that will probably work already, actually. Have I missed anything off? Let's try building it and see. So I've got my add method, and we've got size here. We haven't got get. So let's go to ring.h and add it's going to return type t, and we can make this a reference because the STL containers, normally they return references to values that are in the container, and if you remove that value from the container, your reference is then invalid, and you just have to be aware of that when working with the container. But of course it's more efficient to return a reference than it is to return a whole value, which involves copying it. So we need to pass in a pos to say which value we want to get, and then we just return m_values and pos. So it's the user's responsibility to check that pos is not off the end of the buffer. With at least the implementation of vector that I'm using, for example, you can request a value off the end of the vector. I'm pretty sure that doesn't throw an exception, it doesn't check it, but your code obviously isn't going to work, so it's the user's responsibility to make sure that this isn't off the end of the buffer here. So now let's build this project, and hopefully it will work. Let's run it. So we can see now that, yeah, we've got 4, 2, 3. If we didn't add that 4 on, we would have 1, 2, 3 like this. But as we start adding more values, then the buffer kind of loops around and back to the beginning and starts writing values at the beginning again, which is what a ring buffer is. So now we've got 4, 5, 3. Okay, so that's it for this tutorial. Until next time, happy coding.